Okay, hello everybody. Today we're going to be talking about the lab where we're going to be working with a calibration curve. And so on this slide, I just have this sort of big definition that I copied from a website. And so basically, calibration curves, I'm going to read through this and sort of discuss it as we go along, are used to determine the concentration of unknown substances based on previous measurements of solutions of known concentrations. The precision and accuracy of the measurements are dependent on the calibration curve. So if you have a really good curve, you're going to have really good measurements. A bad curve, bad measurements. The better the curve, the more accurate the answer, or vice versa. And this is a comparison method where we're comparing a known against an unknown against known values. And they're used in all different types of measurements, all different types of machines. And so basically the idea is to make a calibration curve. And usually we talk about it with solutions with varying concentrations. When I have a solution with a particular concentration and I vary that concentration, there are measurable values that will change based on changing the concentration. So for example, if I make it more concentrated by adding more solute, dissolving more substance into it, the density goes up. Potentially its electrical conductivity goes up. Its color might get darker. It might transmit more light. And so I can have a measured value that corresponds to the concentration, and I can use those measured values to predict unknown values. Now, what we have here on this slide is a picture of something called a spectrophotometer. Now, what this is it's a tool that measures the absorbance of light of a particular solution. So what you do is you make different concentrations, you put it in this special tube here, you put it into its chamber, you close the lid, and this will tell you how much light the solution absorbs. Based on a calibration curve, which I have on this side, I can get that absorbance measured from the machine. So let's say I have an absorbance of 1.1. I can go across to the curve, I can come down, and then I know that my concentration is somewhere between 25 and 30 parts per million. Now, in order to use this machine, I need to have or produce or make a calibration curve. So what you do is notice there's dots that are right here, pretty much right on the line. So you would make a concentration of 5 ppm, get the absorbance, 10 ppm, get the absorbance, 15, get the absorbance. And then you plot it, and that's our curve. Now, calibration curves are really only useful if we get a linear line. So we get a straight line. And then I can get the equation for the line, and notice we have an r squared here of almost exactly 1. It's 39, so 0.9998. This is a pretty good curve. And we have a very good relationship between the data. So increase in the concentration increases how much light that solution absorbs. And now what I'm able to do is interpolate or get data values that are in between the points that I have tested. So on this slide, what we're going to do is we're going to use a value from an unknown solution and use the calibration curve to figure out, well, what is that concentration? So if I have an unknown solution with an absorbance of 0.970, what is its concentration? You cannot do this type of problem without the provided curve. So we can have two ways that we can do this. First, we can just use the curve. Now, if we just use the curve, I have a value here of 0.970. That's how much light that this sample is absorbing. I go onto my y-axis. I find 0.97, which is about here. I'm going to go across till I hit the line, and then I'm going to come down and read this value here. And it's probably about 24 ppm. Now, ppm stands for parts per million. So if I have a million, if I have a million total parts, only 24 of those are what we are looking for in this particular solution. Now, this is one way, and this is not necessarily the best way because on this lab, you are going to be graded on your percent error. You're going to be graded on whether or not you are within, for level 2 and 3, whether or not you're within 5% of the value. And for 1 in honors, whether you're within 2% of the value. And so the other way to do this is to use the formula that I have here. So y equals 0.0192x plus 0.5397. This value here is the y value. I put that into my formula, I solve for x, and that's going to give me a much better value with better significant figures for my value for the concentration. So it's going to be 0.970, which I'm plugging in for the y, 0.0192x plus 0.5397. And to solve for this, and I'm doing this because I'm showing the algebra because this is for all levels. So I need to subtract 0.5397 from both sides. And I get 0.4303. And that equals 0.0192x. Now I divide both sides by 0.0192, and I get 22.4 ppm equals x. And notice by reading the graph, I got a value of 24. Here I got a value of 22.4. This is a more trusted value. You can trust this more because we're using the formula for the line and we are not doing estimation in between the minor grid lines. Now, what we are doing in today's lab is we are going to either be generating a calibration curve for percent sugar, or the curve will be given to you. So for a level 2-3, I am going to give you the calibration curve that I created, and you're going to need to get the density of 2 unknown solutions, use that density to determine the percent sugar in the unknown solutions. For level 1 in honors, you need to make your reference solutions, make your calibration curve, and then use that curve to get the concentration of the unknown. Now, what we're going to do is with the curve, my lines are a little crooked here, you're going to make a graph. So for the level 2-3, I'm giving you the graph. The y-axis is going to be the density of the sugar solution in grams per milliliter. The x-axis is going to be percent sugar. And we're going to have 0% sugar, 5% sugar, 10% sugar, 15, and 20. And so what we're going to do is you are going to determine the density of, particularly for 1 in honors, you're going to get the density of each of those known concentrations. You're going to plot it on a graph. You're going to get the line. You're going to get the equation and your R squared. For the level 2-3, I'm giving you the graph. Once you have your unknown solutions, you're going to have to test 2 unknowns, and I'm going to have more than 2 choices up front. So you're going to have to choose 2 of however many I happen to make. And you are going to determine the density of the unknown using the technique described later in this video. Once you have that density, you use your equation, or you could use your graph. You use whichever one that you feel more confident with. And so let's say your density is right here that you have determined in the lab. You are going to come across till you hit your line. You're going to come down and you will read the value off the graph. You are then going to get the density of your second solution. And let's say the density of your second solution is here. Use your equation. or use your graph, come across, come down, read the value off your graph. So the purpose of today is to either use the calibration curve that's given to you or the calibration curve that you've generated in the lab to tell me what the percent sugar is in two unknown solutions.
Okay, for this part of the lab, I have the equipment set up. This is the second part. Now, if you are level 2, 3, you didn't do the first part. I provided you with the calibration curve. If you are level 1 and honors, you now have made your reference solutions and you are now ready to determine the density using what is called a pipette. Now, this is a pipette. This is something called a volumetric pipette. Now, there are two classes of glassware. One type of glassware is a to contain type of glassware, and one is a to deliver type of glassware. A graduated cylinder is a to contain. When I measure out a 25 ml sample of water or something into this graduated cylinder, it contains 25 milliliters. Then when I pour it out, it doesn't necessarily deliver 25 mils because there's some liquid left behind. This is designed to deliver a set amount of liquid, and this particular one, because it's a volumetric, it only can ever deliver 25 milliliters. Now I'm going to show you how to use this, and so again, you should be taking notes because I'm not giving you written instructions. This is the instructions that I'm giving you right here verbally. Now the equipment that you're going to use, we have our pipette. This is a pipette filler, and I'm going to show you how to use it. You're going to have the solution that you're going to test, whether it's your reference solution or the unknown solutions. You're going to have a balance, and you're going to have a cup. You're going to have something to contain the liquid to deliver into. And then you're going to have your spot where you can write your data down. Okay? Now let me talk a little bit about the pipette. This is the tip end. That's the end where the liquid comes out. Okay? Up here, at the top of the pipette, there is a ground glass line. Sometimes it's ground glass, sometimes it's marked. I'm trying to get this into focus for you. There's a line right here. That is always the spot where you want the volume to be. That is always the spot where you want the meniscus, the bottom of the meniscus, to be at this line. And once you filled it up, you get the meniscus to that line, then you know you have 25 milliliters. Now, how you use this, first, you're going to be very careful of the tip end. You never take this and jam it down into your solution and push it down into the table. Okay, so what I see kids do a lot is they push it onto the table. Do not do this. And then take the filler and put it on this while it's pushed onto the table. You never do that, okay? Also, when you go to put the filler on, it goes on the flat end, not on the pointed end. Okay, and you don't hold it way down here and put the filler on up here, because what happens is it acts as like a lever and it can snap in your hand. You always want to hold the pipette as close to the top as possible, and then you put the filler on it. So you put the filler on, do not jam it on, just push it on so that it's snug. Okay, when you have it on there, this part right here should be all the way down. Now we have a lever that you're going to turn down. This is going to rise, and as this rises, it is going to pull the liquid up into the pipette. So, or the burette, excuse me. No, pipette, I'm sorry. Boy, end of the day. So you put it into the solution. Let me see if I can turn this up a little bit and maybe move it back. Okay, so while it's in the solution, you are going to dial this slowly up, okay? And as it dials up, if you look down here, the liquid starts to come up. Now this filler is designed for a 25 ml pipette. So you should be able to fill this with one application of the filler on the tip of the pipette, and the liquid starts to come up. Now, these are meant to have a good seal so that you can really kind of dial in the volume, but it doesn't really get a good seal. So what's going to happen is you are going to allow the liquid to come up above the line. The line is right here, okay? Never have the liquid go up above into the filler. You then are going to very quickly pull the filler off and put your thumb on it and pull it out of the liquid. So you see how my thumb is on there? Okay. Whoops, sorry. Then what you're going to do is you're going to hold it over whatever it is you're trying to, well, hold it over your source, hold it over your sample. And this takes a little bit of practice. I'm trying to hold it so that we can focus and see the line. Where's my camera? It's kind of hard to get the focus. You're going to gently lift your finger, and do you see how that liquid is slowly coming down? You're going to lift it so that that meniscus drops, and then you're going to push your thumb down to stop it when the meniscus is at, oh, I had it clear for just a second. Oh gosh, it's because it's, I think, see-through. Okay, once you have it at that point, you now have 25 milliliters in this pipette. You are then ready to deliver into your cup. So what you're going to do is you're going to turn your balance on, you're going to put the cup on, and you're going to read the mass of the cup. So I have 8.90. Do not hit the 0 button. Okay, just leave it as is because we'll subtract this out. Then you're going to hold this over the cup and just lift your finger off, and you're going to let it gravity drain. Now, as it's draining, obviously the mass is going to increase, but what's happening, you are delivering exactly 25 milliliters. So at the point in the lab where you have to get the density, we're getting the mass right here with the balance. The volume is always 25 milliliters, okay? And so when you divide to get your density, it's going to be the mass that you calculate by subtracting out the cup divided by 25 milliliters. Now, one thing I want to note, after it gravity drains, you see that there's a little bit of liquid in that tip? Leave it there, okay? And the reason why you leave it there is this is designed to deliver that volume with that little bit in the tip. All right, then I record my mass. It's going to be 33.79. And I write it down. The difference of these two is trial 1. I'm going to do this 3 times, or 2 more times total. So now I'm going to put this back into my sample. I'm going to put the filler back on, holding it up close to the top. Put it on, and then I'm going to slowly dial up the plunger. Now, one thing to note, if as you're pulling the liquid up, let's say I pull it out of the water, oh, I get a big air bubble in there. That's really bad. You don't want any air bubbles. So what you're going to have to do is dial it down and force drain it into the sink so you can start over, okay? Then we dial it back up, but do not take it out of the liquid, otherwise you get air bubbles. That's very bad, okay? So I'm going to dial it up again. I'll show you how to move the thumb one more time. So again, we're going to move it up so that it's above that line. Okay, and you notice how I take it out? Now this one actually is staying put, but I have my liquid above the line. If there's a good seal, you'll be able to dial it directly with the filler. If not, you do have to take it off and use your thumb. So I'm going to take it off and use my thumb. And then I am going to let the liquid, while holding it over the cup, let the liquid drain out. So I went way too fast with that. And to the bottom of the meniscus, and I'm pretty much right there, till the bottom of that meniscus is even with this line, okay? Then I come back over here. I do not have to re-zero the balance. I just add it and record whatever mass it is for my second trial. So each of these we're consistently delivering 25 milliliters. Now before you actually start doing masses, you might want to practice a little bit with just plain water. Practice with water, practice with the tap water. I'm sorry, practice with the distilled water, not the tap. You never want to put the tap water in here, okay? And then what we're going to do, once it's done draining, do not blow that last little bit out, leave it in there, and just record what it is, 58.68. Difference between these two is trial 2. Now for level 1 in honors, if you are doing the calibration curve, always start with lowest concentration and work your way up. So you're going to do 0% first, then 5, then 10, then 15, then 20. Okay? If you are doing just the unknowns, level 3 and level 2, you may just start with the pipette, just with whatever solution you have. Okay? Now, one thing to note, notice I put it here and I kept my hand on it. This is round, it will roll. Okay? So if I put it on the counter and I put it right here near the edge, let me move this back. If I put it right here near the edge, it potentially can roll off if you don't put anything in front of it. Ideally, you always want to put it perpendicular to the counter, so if it rolls, it doesn't roll off the counter, and then just put something next to it so that it can't go anywhere and it can't roll. Now, when you are done collecting your data, so we're going to do 3 trials with each of the reference solutions and with each of the unknowns, you have to clean out your pipette, and you have to clean it very well because the sugar is very, very sticky. And if you don't clean it, you're going to ruin the pipette. So I'm going to show you what to do when you are done. Okay, you get some distilled water. You're going to take the filler, put it on the end, and you're just going to fill this up with fresh water, and you can fill it up about halfway. You're going to take the filler off, put your thumb over it, hold it over the sink, flip it the opposite way, and let the liquid drain out. Okay? And I want you to do this 5 times. Okay? And I know this seems like a lot, but I want you to do it 5 times because then we know we've got it pretty much clean. Okay? And then we dump it. I'm going to do it one more time. Now, in between each unknown, you might want to rinse it out as well because I'm not telling you whether the unknowns are high concentration or low concentrations. You're going to be graded completely on your percent error and how close you are to the concentrations of the unknowns. So start with a clean pipette after you've done your reference solutions if you're level 1 in honors. Do your first unknown, clean it out, do your second unknown, and then clean it out. Okay, I wanted to just tack on a little addendum to the video because I realized when I showed you how to use the pipette, I was using the filler sort of in a way that it's not designed. And I was sort of also out of habit of how I learned to use a pipette with a bulb. We used to use bulbs, and you would definitely have to pull the bulb off and use your thumb. The fillers are designed a little bit different way, but over the years they don't work as well as they should. So I want to show you how the filler is designed to be used, and if you happen to get a good filler, you can actually use it this way as well. So we're going to take the pipette. Remember, you're also going to hold it up close to the end. You're going to put this on, and you're going to put it on so that it's nice and snug. Now don't jam it on, just put it on so that you get a nice seal. And then we are going to dial that little wheel down, and we are going to pull, and I'm going to just pull this down so that you can see what I'm doing. And we are dialing this so that the liquid comes all the way up into the pipette. Now once I get the liquid level above the line, see, this one doesn't have a good seal. Well, maybe a little bit. Okay, what I want to show you is, if I put my finger behind it, I still have the pipette, the filler on here. Now, if this level stays, and I'm putting my hand behind it so it hopefully stays focused, then you can adjust the level of that using the dial without taking this off at all. So if you have a good seal, you can adjust this with the dial, and then when it comes time to empty, you don't have to take the filler off. All you have to do is push this in, which puts air into the pipette, which allows it to drain. So if you have a good seal on the filler and the pipette, you do not have to take the pipette off, and you can use the dial to dial in the correct volume. If you don't have a good seal, then you are going to have to take the filler off and use your thumb.